Hello, welcome back to Cracking the Cryptic, and thank you as always for coming to spend some time with us having a look at a Sudoku problem. This one is called Bank Shot by Sotek, and yeah, this gives me a chance to explain about the differences between British and US terminology in billiards, pool and snooker. I made an absolute mess of claiming that I knew about American football terms recently when I thought that the opposite of a strong safety for some reason was a weak safety, when I know perfectly well it's a free safety. Apologies for that. But a bank shot is what we in Britain would call a double, which involves hitting a ball off a cushion or rail in America towards its target, and that could be the cue ball or the object ball. I don't know what they're called in the US. There are some other differences between US and UK terminology and sort of cue sports. A plant is what we in Britain would call a combination shot, I think, in the States, and a cannon here is a carom there. And one of my favourites is well, there's also screw or screwback, which is draw in America, but side spin, which is generally called side here, is ironically called English in America. So there are some very weird differences between all the technical terms involved in pool or snooker. So that's just by way of background. The puzzle is called Bank Shot. Let's have a look at the rules in a moment. Don't forget, you've still got a few days left on the puzzle hunt, a Sudoku Hunt This Is by Peter C. Hayward. That's on Patreon. Do join us there if you can, and loads of apps and merch all available. There is our Bobbins mug, which is very popular. Now, the rules of this. Normal Sudoku, this is by Sotek, who's often done brilliant puzzles before, keen follower of the channel. Normal Sudoku rules apply. Digits in cages must sum to the value in the top left corner of the cage, so these 4 digits add up to 20. Digits along arrows must sum to the digit in the attached circle, and the digits connected by a white dot, there is only one such, must be consecutive. So we could have 5 and 6 there, for instance. Not all dots are shown. So those are the rules. Obviously we have normal Sudoku rules to help us as well, but looks interesting. Do give it a try. I'm going to start now. It's on the link under the video. Let's get cracking. Now, bank shot. I mean, I suppose these are kind of balls, almost all going to the cushion. Is that the point? Going to the side of this table? I don't know. I don't know really what that's doing, but that is the title. Right. If that equals 22 and this equals 11, there is a secret about every row, column and box in a Sudoku. They all add up to 45, and that's because that's the sum of the numbers from 1 to 9. So along the top here, this row adds up to 45. We can clearly tell that these 7 cells add up to 33. 45 minus 33 equals 12, which is the total of these two. Oh, it's a sort of, yeah, that's the same as that. Maybe there's a sort of set theory going on. So the blue digits obviously have to be a set of the digits from 1 to 9, because that's one row. So do the yellows. Now, they're all a set of the digits from 1 to 9. If we eliminate that cell, then we must still have the same 8 digits there and the same 8 digits here. Now, if we just consider the total of those 8 digits, which again must be the same for blue and yellow if they're the same 8 digits, we can deduct the same amount that's on those two as is in that, because the 2 on the arrow add up to the digit in the circle. So now we know that the blue cells add up to the same as the yellow cells, and the blue cells add up to 33. The yellow cells therefore add up to 33. If we take off the 20 in those 4, these two add up to 13. Oh, and we can do the same sort of okay, it's not really set theory. Well, I suppose it's like an introduction to set theory. Yeah, okay, that's all true. And these two add up to 13. Okay. And the other way to look at that is that these three add up to 13. Why do I say that? Well, that plus that equals 13, and that is equivalent to those two because of the arrow rule. So those two plus that therefore add up to 13 as well. So, I mean, you can see it a lot more simply than most set theory things. But now we know those add up to 13. These add up to 28. 13 plus 28 is 41. Subtract that from the 45, which the bottom row adds up to, because they all do, and you're left with 4, which must be in this cell. So that's our first number, is a brown in the corner pocket. Right. It doesn't tell me how to make the 13 here, or the 13 here, or the 12 here, which I now see is the same as 12 here. Yeah, I didn't really need these coloured. Sorry, the way to do this more simply is to say 45 minus 33 equals 12 in those two cells, because that is the same as those two. Those three are 12. Plus 20 is 32. From 45 means those add up to 13, and those are the same as those because of the arrow relationship. Now, can we use the 4? I don't think it works as well up here. I mean, those three are the same as that, are the same as those, and I don't see... Oh yes, I do. This is a classic arrow Sudoku trick. These 5 cells have to add up to at least 15 in normal circumstances, because 1, 2, 3, 4, 5 are the lowest 5 different digits. Now, you will see that in this puzzle, they can't include a 4. So the lowest 5 different digits in this column up here are 1, 2, 3, 5, 6, which you will be aware, dear reader, add up to 17. And that's very telling, because that's the least those 5 cells can add up to. The most these 2 cells, which add up to exactly the same thing because they represent the totals of these 2 arrows, can add up to, as 2 different digits, is 17. So those must be 9, 8. This must be a 1, 2, 3, 5, 6 combination. And then in the rest of the column, we have 7, 8, and 9, just because we've eliminated 1, 2, 3, 5, and 6, and 4. This 7, 8, or 9 is on a white dot. So this cell has to be a consecutive number to that. And it's 6, 7, 8, or 9. But wait, it's not 8 or 9 because they already appear in the column. So that's 6 or 7. And now this can't... Oh, this is brilliant. Now this can't be 9 because that wouldn't be consecutive with either 6 or 7. So that can be 7 or 8. 9 in this column must be in one of these 2 cells, and therefore this is not 9 because it's in the same box. That's really pretty. This is the bank shot. It bounces around that cushion, down that one, around here, up there, over to here, and then back down to there, and there's the object ball, if you like, that we've suddenly established because we know there's a 9 in one of those 2 cells. This one is an 8. That must be what it's about. That's brilliant. So we can take 8 out of those 2. That's now a 7, 9 pair. That means this cell is 8. To be consecutive, this one is now 7. Now we can run it along the top rail again, I guess. These 2 add up to 7 more to make this 22. And these 2, we decided earlier, add up to 12, and they can't have an 8 or a 7 in. So that's 9 and 3. Now, be careful. You'd be tempted to put the 9 in the circle. But that could be a 3 if you had 1 and 2 on there. So, what can we do with that? I'm not sure, actually. If that was 2, 1, yeah, those would still work. This pair we said adds up to 13. Okay, I'm not sure. Oh, look at this cell. Oh, that's pretty. This now has a 9, 8, and 7 in the column, but we know that it adds up 3 separate Sudoku digits. The minimum they can be is 1, 2, and 3. The maximum this can be now is 6. So there we go. That must be what it is. Now this cell sees 6, 1, 2, and 3. So that's a 5. That's on a 9 arrow. So these two must be 1 and 3 as a pair. So this is a 2, 6 pair on the 8 arrow. Now the 8 arrow has a 3 cell arm here. So that must have a 1 in it. It's either 1, 2, 5 or 1, 3, 4. Okay, I'm not sure what to do. Right, this 5 sum doesn't it? Sorry, a 7 sum, 15 and 7. It doesn't include a 3, so it's not 3, 4. So it's either 2, 5, which would be that way around, or 1, 6, which would also have the higher number on the right. The 11 cage must have a 4 in it, and it must be either 4, 1, 6 or 4, 2, 5. Oh, look in this row. Where's the 9 going to go? Remember, there's a 9 pair, a 9, 3 pair in those cells, so those can't be 9. That's where 9 goes in row 2. We get a 4, 8, 7 triple here, so that's not where 4 is in this cage, even though it must be in there somewhere. So it's in one of those two. These 3 add up to 16, and they've got to include 8 and 7 because they don't appear in any of these candidates. So this must be 8 plus 7 plus 1. So now we know there's no 1 there. Well, there's me here. So there's a 1 there. That gives us a 2. That gives us a 5. This doesn't have 2 and 5 in anymore. It's, oh, and there's 1 in these, somewhere in these 3 cells, so not in those 2. So that's a 4, 6 pair. This is a 1. This is a 2, 5, 6 triple. That has become a 3. 4 and 9 can be placed. The whole of box 1 is suddenly done already. Now this circle and arrow gets interesting. This can't be an 8 because the minimum would be 10. This can't be a 6 because the minimum would be 10. So it's either 7 and 2, 4 and 5, they both give 9, but it could be 4 and 2 making 6. There's a 1, 2 pair used in this box already, so that's a 3, 5 pair. Now we get to place 1 and 2 down here, and clearly this can't be a 1 because we know there's a 1 on the arrow. So 2 there, 1 there. Now the arrow must be 1, 4, 3. And this one must be a 3 because 1 and 4 are in the box already. This is a very elegant puzzle. 5, 6 pair there. 4, 7, 8 are the triple in those cells. This 9 goes with either, well, 2 or 1 I can put in as candidates there. I can't put 5 because of that. So I'll take 4 out of that cell as well. Now we've got 2, 3. Right, this... I could try and work on what the combinations to make up this 28 cage are, but the simpler way is to remember that this row equals 45, minus 28 and 4. Oh yes, we learned earlier on, these add up to 13. Now, they can't include a 1 and a 4. They must include at least one of the numbers between them. If they had both of them, this would be a 2, 3, 8 triple. And if they only had one of the numbers between 1 and 4, they'd need 2 of the numbers above 1 and 4. That's a knowledge bomb. And the only way you could do that is by minimizing everything and having 2, 5, 6 here. But look, that would break this cell, which needs to be 5 or 6. So you must use both of the numbers between 1 and 4 here. This is a 2, 3, 8 triple. 8 can't be on the arrow because that would be 10 or 11. So we get a 5 there, 8 there. And we are firing now. So that can't be 8. That can't be 5. 9 could be made up. Well, it can't be 3 anymore because we can't get a 1. Well, ever since we got a 1 there, it couldn't be 3, but I've only just noticed. This must be 7, 2. That fixes this triple and this triple. And it puts 9 in this circle. 9 in this cage must be there, or rather in this column must be there. That's how I deduced that, not from the cage. 1 there. Now what about this? Look, this cell sees 2, 3, 1, 4, 5, 8 and 9. It's 6 or 7. This one sees a 4, a 5, a 2 and a 3 and a 6. And it's got to be less than 7. So that's a 1. This must be, because of that, must be 5 or 6, and it can't be 6. So that arrow is suddenly complete. That 9, actually, I've just spotted, is looking across there, fixing those two. 7 and 8 to finish the row. Ever since we had a 9 in this column, this 21 cage was 6, 7, 8, and we can fill them in now. That 6 fixes the 5, 6 pair. The 7 that we just put in makes this an 8. That does the 9 arrow. And I think, I was going to say all our arrows are completely done, but not quite true there. Actually, or here. So getting a bit premature on that. 8, 7 are looking at that cell, so it's a 1. 6 is looking at that cell, which makes it a 4. We've got 2, 5 and 3 to put in these, and 2 and 3 are looking straight there. So 5 there and a 2, 3 pair. These are 7 and 9, and I don't know the order. These are 2 and 3, which looks like a deadly pattern, but look, it's in the 11 cage. So that has to be 8 or 9, has to be 9 therefore, because there's an 8 in the row already. That unwinds a supposed deadly pattern of 2s and 3s. The 9 looks there, 7 and 9. The 7 looks here, 7 and 8. I've got a 4, 5 pair that I can fill in. That sorts out 4, 7. Also makes this a 6. Still can't do the 2, 3 or the 2, 6. This is 6 and 8. That's 2 or 3 as well from the row, and in the column that means 8 is here. This is a 4 to finish the row. We've got a 2 here, naked single, 3 or 7. Well, it's got to be 7 there. That's the only place 7 can go in the column. So let's just finish off the last few cells and praise the author for a very entertaining puzzle. And I'm sure it was all about the rebounding of the bank shot around the rails of this pool table. Very nice puzzle, most entertaining, not too difficult. Didn't really require set theory at all. It just required counting, and I'm okay at counting. I'm not quite so bright at knowing exactly where set theory needs to be applied, it would seem, but lovely stuff. Thanks to Sotec, and really enjoyed that. Thank you as always for watching us on the channel, and hope to see you again soon. Bye for now.